Today, we're going to learn a little more information about an antiderivative, okay? So in your other previous math courses, you have learned how to take the shape or the area of a shape that is bound like a square or a circle or a triangle. You know how to calculate the area of those shapes. Well, today we're going to learn that the antiderivative, if I take the antiderivative of f of x dx, the integral of f of x dx, that means antiderivative. But if I add boundaries, if I put numbers on that integral sign, that is going to mean that you are finding the area under a curve from A to B. So you're going to be able to find areas under a curve, which means curved area, like it doesn't have to be a straight shape that you already know how to find the area of. So as a picture, we're not going to learn yet how to find the exact area. We're just going to learn the approximate area by using rectangles. So here, if this function is f of x, and I have a boundary here of A and a boundary here of B, the area of this shaded region right here is from A to B, f of x dx. So this notation means you are calculating the area under the curve, but you're stopping at the x-axis. All right, we're not going below the x-axis. We are bounding it by the x-axis. All right, so here's another function. We'll call it g of x. If I have a stop it or start it at A, stop it at B, this area would be the integral from A to B of g of x. Okay, so eventually we're going to put things together and you're going to learn how to calculate that area. But today we're just going to be using rectangles to approximate the area. Okay. So remember, the area of a triangle, the area of a rectangle is base times height, right? So what we're going to be doing is we're going to fill this region with just rectangles. We're going to find the area of each rectangle and then add them together. So when I look at this rectangle, let me draw one over here. This is going to be the base of my rectangle, and that's going to be delta x. The height of my rectangle is right here, and that is going to be the value of f of x at that x value. So we use the function to find the height of the rectangle. So that's what these things say here. Delta x is the base of the rectangle and f of x is the height of the rectangle. Well, there's three different types of rectangles we can draw. We can draw left rectangles, which means the left corner of the rectangle touches the function. We can do right rectangles, which means the right corner touches the function. Or we can do midpoint, which is the middle of the rectangle touches the function. And the more rectangles we have, the better the approximation. If f is increasing or decreasing, that helps you determine if your estimate of the area is over or under. So hopefully, I want these pictures to kind of show you what we're doing here. So what corner in that first picture is touching the function? Right. So these would be called right rectangles. Okay. This here is your delta x, is your change in x. So that, I think it's 1 to 2. So that would be 1. And then the height of my rectangle is the value of the function at 2. Okay. What corner is touching that one? Left, so this is a picture of left rectangles. And the last one is the middle of the rectangle, so this is the midpoint. All right, so the first picture, is F increasing or decreasing?
It is increasing.
If F is increasing and I'm using right rectangles,
So it's an over.
so it would be an over approximation because the actual approximation is like that area. So your rectangles are overestimating the area under the function. Or, yes. This one, my function is increasing and it's using left rectangles. It's an underestimate. You see the little space.
Yeah.
So the areas of the rectangle is going to be a little bit less. Midpoint is almost perfect because this little piece over here and that empty
Equal.
space kind of fill in. So they will, if you're doing midpoint rectangles, they're never going to ask you if it's an over or an underestimate. Right here in this box, it tells you if it's an over or an under. I personally don't remember that. I just draw a picture. If you draw a picture, you're going to figure out if it's an over or an under.
Well, we have to figure that out for trapezoids also.
Trapezoids, yep, we're gonna. It's very hard to tell if trapezoids are over or under. So that one is kind of one that you have to like memorize. Okay, so we don't just use rectangles, we can also use trapezoids. Trapezoids give us a better estimate. And you are all used to drawing a trapezoid that looks like this, right? Our trapezoids are gonna look like that. Okay, so it's, if you turn your head sideways, this is actually the height of our trapezoid. This is gonna be like the base 1 and this is base 2. So area of a trapezoid, if you forgot the formula, is height over 2, base 1 plus base 2. And that's what our trapezoids look like. They don't look like this. If you want to see it on the side, it's like that, is what our trapezoids look like, but going the other way. But your delta x is still the height of your trapezoid. And f of x is used to find base 1 and base 2. So if you can see here, like there is your trapezoid. So base 1 is the height at 0 and base 2 is the height at 1/2. And then so base 1, base 2, and that's your height. And the next trapezoid, do you see that they share a side? Okay, so today we are just going to use tables to find approximations for area under the curve using right rectangle, left rectangle, midpoint, and trapezoids. But I want you to see a visual. That's what this link right here. All right, so let's start with. All right, so here I have a quadratic. And what rectangles is it using?
Left rectangle.
Left rectangles. Well, look at what happens if I increase the amount of rectangles.
Stays left.
It's more
precise.
It's more precise, right?
Precise.
And this is not a coincidence that they labeled this N. Remember yesterday, we found the limit as N approached infinity. Because we are gonna have infinite rectangles. A little preview. All right, so that is left. Let's look at. That is right. And then midpoint. Okay, so again, as I get more and more rectangles, the better the approximation. All right, this, that link, I mean, you can play around with looking at different functions too. I want to show you that if I change this to a minus, you see how some of it drops under, but it's still the area between the function and the x-axis. Okay. All right, here we go. So our first example is going to be right rectangles. I want to sketch a picture first so that you can make the connection of what you're doing. You do not need to sketch a picture. I'm hoping by the end of class, you're going to think this is super easy and you're not going to have to write any picture or draw because you'll understand it. But if I were to plot these points, 0, 19 might be up here somewhere. 2, 18. 5, 11. I'm just approximating. 6, 9. And then 9, I'm at 1. I have no idea what it looks like, what the function looks like. I could connect these points with just connecting them. It could go up and down. I don't know. But it's going to go through all those points. Okay, so that's my function f of x. Well, what is this asking me to do? It's asking me to use Wright-Riemann sums. Well, Wright-Riemann sums is a fancy way of saying right rectangles. And they will always have to give you that information. And then they're always going to have to give you how many rectangles they want you to use. So this is telling us they want us to use 4 rectangles, 4 subintervals. Take 0 to 9 and divide it into 4 rectangles. So in my picture, I am going to take, because I only know these points, I have to use those points. And I'm going to draw the right rectangle, which means the right corner is touching the function. So when I draw this rectangle right here, that's the base, the height is that side. Because the right corner is touching. So when I draw my next rectangle, this is my height. And then this rectangle and that rectangle. And then all you're going to do is find the area of that rectangle using base times height. So what is the base of this rectangle?
2.
2, and what's the height?
18.
18. So the area of this would just be 2 times 18. Or 36. That middle rectangle would be what?
3 times
3 times
11.
11, so 33. And then
One,
1
uh,
times,
9.
so 9,
9.
and 3
3
times,
times 1.
which is 3.
Add
So the estimate from 0 to 9 of f of x dx is 36 plus 33 plus 9 plus 3, which is what? 81.
So then what is
All right, so now I'm going to do the same problem, but without the picture using the table. Because how many of you want to draw and plot all those points? You don't want to, right? So using questions on that picture? All right, using the table, if I go here to here, there to there, how many rectangles is that? 4. If I find the difference in my x's, 2, 3, 1, 3. What are those values giving me? The base of the rectangle.
Points in the base.
Now, these two are the sides of the rectangle, but which one is touching the right one, which is that? So to find this, I am going to be using 2 times f of 2, which is really 2 times 18. Plus, the next one, the base is 3. The height is going to be f of 5, or 3 times 11. The next base is 1. Height would be f of 6, which is just 1 times 9. And then my last rectangle is 3 and f of 9, which is 3 times 1. Right? Not difficult. All right, I want you to try the other one on the notes that says right rectangle. So I think it's on
Last page.
last page. This one, the one that says 4 to 19, I want you to try this one.
Right side.
Yeah, if you want to get out your calculator to add the numbers, that's fine. If you have the answer you want to ask me, I'm happy to tell you if you got it
I
right.
have it. Oh, I mean, no, I don't have.
No.
She get on. I thought you meant like.
Did the wrong question.
Oh, no, I did that.
Miss Cook.
Yep. Go get it.
Can't get it out.
That's the difference.
What you got?
Okay, so if. For
Wait,
this,
I'm the one that did it.
why is that for this file?
Two artists. I got 4 of your rectangle, which one's gonna be close.
You did everything right.
I'm gonna, so that's gonna do 3 times.
Those are big numbers. It's just big boy numbers. I'm trying to, it's right. It's right. I realize. What you getting?
Oh, someone put this in the wrong way.
I got 360. Wait, it's just 300. So it's just, it's that. It's not.
Yeah, this time, upper bound, this time.
Yeah, that's exactly how we do it.
I got 4. So.
This time.
Should get 12.
Let me see. Better than mine.
On upper bound.
Come on.
Because the general curve of this is like,
So now it's 23. I did the right thing, I put the wrong number.
You have to make sure you're doing the correct problem. That's the first problem, that's the first issue. Now, if you are having difficulties putting it in function notation, because sometimes it will be in function notation, and they encourage us, College Board encourages us to write it in function notation. If you understand what you're doing here, do that step first, and then you can put it in function notation. Like, where did you get this 18? That 18 is f of 7. Okay, so you could have written this as 3 f of 7 plus 4. Where does that 24 come from? F of 11. And so on. So because on your final exam, if it's an FRQ, you don't have to find the answer to that expression. If it is all numbers, you can leave it. And sometimes we've seen points where you get a point for the answer and a point for the Riemann sums. And so for that problem, this, I guess, would count as both points. But I want you to understand the function notation, because when we give you an actual function and you're using your calculator, using that function notation is going to be helpful. All right, so this one is just 2 times f of 13 plus 3 times f of 16 plus 3 times f of 19. Sometimes when I do these problems, when they tell me it's right rectangle, I immediately cross out my left end because I know I'm not going to use it. And that helps me remember, if I use that, I did something wrong. All right, left rectangles is exactly the same, except which side are we going to use? The left. Oh. This one, left Riemann sums. And we want 4 subintervals. So this, I'm not going to draw the picture. All right, so here, 2 to 3 is 1, 3 to 4 is 1, 4 to 5 is 1, 5 to 9 is 4. Because I'm doing left rectangles, I'm going to go ahead and cross out my right endpoint because I'm not going to use it. I'm using the left side. So what is this going to be? It's going to be 1 times, which of those, 13 or 18? 13. Plus 1 times 18. Plus 1 times 19 plus 4 times 21. If you put it in function notation, it's 1 times f of 2, 1 times f of 3, 1 times f of 4, and 4 f of 9. Nope, 5. And what do we get?
Not 135.
134?
134.
Yep.
James Cook, I've already said this, but like, do we have to write that?
All right, a lot of people are asking me, do we have to write the f of x? I'm going to tell you on Monday, we are going to be doing these problems, and I'm going to, instead of a table, I'm going to give you an equation. You're going to be using your calculator, and you're going to want to type it in your calculator using like Y1. Like, you're going to want to understand this notation. So I would encourage you to try to understand it so that when you have a calculator to do problems, it makes it easier.
But like, if it was just like the table question, could we just write?
Yes,
out, like,
you could just write this part.
Okay.
Yep.
Yes.
Yep. All right, midpoint. So midpoint Riemann sums and 3 subintervals. So with midpoint, whoa,
It's just the itself, correct? Oh, wait, no.
Oh, it's the function.
so with midpoints, what you're gonna be doing on your graph is you're gonna have 3, 4, 5. So the base of my rectangle is still this entire thing, but the height of my rectangle is the one in the middle. Okay, so when I'm looking at my table, I have to jump over and jump over and jump over. I'm only doing 3. If I went to every single one, I would have way more than 3 rectangles. I only want 3 rectangles. So the base is going from 3 to 5, which is 2. Then it's going from 5 to 7, which is 2. 7 to 9, which is 2. And then the height of each rectangle is the number in the middle of the rectangle. So let's write this out. So
Interesting.
to approximate from 3 to 9 f of x, it's going to be 2 times 20 plus 2 times 16 plus 2 times 10. But then using function notation, it's 2 f of 4, 2 f of 6, and 2 f of 8. And what do we get?
92.
92 is correct. All right, I'm going to give you like 3 minutes, 4 minutes to try the left and the midpoint one on the next page. I want you to try this one, that's 0 to 7, and the 4 to 20. And I'm just gonna put up the answers so you can see if you got it right. I'm not gonna go through and show you.
Yeah, please. You go at the rest paper on the desk. You keep giving him paper? Not me. You sent paper at that first line.
Wait, no.
No, I will agree for all the answers.
Are the midpoint ones always gonna be like the same interval and? Midpoint one is always gonna be the same.
Yeah, it just happened.
Parents of music from the leader.
That was a little sound.
We use the trapezoid.
All right, did we get 73 and 546? Yes, ready for the last one? Trapezoid?
It's like a 4 or 5 for you.
Listen to me. You have to reach out this. And what's in that?
Nobody in this world.
Okay, well.
Business saga.
The truth is.
Natural.
Okay.
There are substitutes.
No.
Thanks. I have no idea.
It's like the same.
Look, Eric.
It's like everything's the same, but they tell you like, using five something.
Okay, so they're not gonna give you a table where midpoint won't work. Like, and they will make it so that you, yes.
Oh, hi, I was wondering if you had any extra copies of the worksheet due Monday?
So there's no issue. I got 273, you just have to add 4 names.
All right, mid or trapezoids.
I doubled it. 4 times
So this one is trapezoidal sums,
4 times.
and we have 5 trapezoids. So again, the picture is looking like this. So down here is your height, which is your change in X. The base 1 of the trapezoid is the function value and base 2. And then for my next trapezoid, this is base 1 and this is base 2. So they share a side. All right, so let's break this chart up into 5. So 1, 2, 3, 4, 5. And let's figure out the distance. So that would be a 2, 2, 4, 3, 2. Remember, area of a trapezoid is base, not base, height. Height over 2, base 1 plus base 2. So to approximate from 0 to 13 f of x dx, these are the heights and these numbers are the bases. Okay, so 2 divided by 2, base 1 is 8, base 2 is 15. Then my next trapezoid. Height is 2, cut in half, because that's the formula, height divided by 2. Base 1 is 15, plus base 2 is 20. The next trapezoid has a height of 4, divided by 2. Base 1 is 20, plus base 2 is 31. A lot of these. Why did they have to go this side? 1, 2, 3. All right. Next trapezoid, height of 3 over 2. Base 1 is 31 plus 43. And our last trapezoid is 2 over 2. 43 plus, I ran out of room, 44. And again, if I put this in function notation, oh my gosh, because there's 5 trapezoids. That's just writing in a function notation. Do you have to do that?
No.
No, but should you understand for when we do functions and use our calculator? Yes.
Wait,
Somebody typed it in and what did you get?
why did you?
99.
F of zero.
170, you tied it?
Whoa,
I got 358.
I got 358.
Did you just switch it up with F of zero, just to show us like what it is?
I was putting it in function notation.
Oh,
So like this 8
yeah.
is f of 0. This 15 is f of 2. And then f of 2 and f of 4. All right, try the last one and see if you can get it correct.
Oh, I started subtracting.
What's wrong with doing? The very last one? or
The only one you haven't done yet. So that would be this one,
The mid, capital Y.
trapezoidal sum. Oh, this one's only 4, luckily.
I did it all wrong. What's Calvin?
I got a decimal too, it makes you feel better.
I don't think I've ever got to 40. Got 124.5.
I think it's different for you. But yeah, I was thinking about it too. Yeah.
No, I don't. I got there.
All right, you should get 124.5. Okay.
I got 142. I gotta get 142.
Second one.